All right, folks, I'm just going to go over how to do these two example problems on the word equations assignment. So in example one, it says zinc metal will dissolve in hydrochloric acid to produce dissolved zinc 2 chloride and hydrogen gas. And then there's a hint on here. The zinc 2 ion has a +2 charge. So there's a few cases on here where I'll give you some transition metals. And those metals have a Roman numeral afterwards. Whatever the Roman numeral is, that's the positive charge of the ion. So since this is zinc 2, it has a +2 charge. We'll go over that when we need it. Okay, so let's dissect this sentence and turn it into a chemical equation. So first up it says zinc metal. So we're going to write out zinc. It says zinc metal. Then it says that will dissolve in hydrochloric acid. And I tell you that the formula for that is HCl. We're going to say plus HCl, because that's hydrochloric acid. To produce, now whenever you see that produce, that means write the reaction arrow. To produce dissolved zinc 2 chloride. So I'm going to write out zinc chloride. Now, again, this is zinc 2 chloride, so that means that the zinc has a +2 charge. For the chloride, we're going to need to look at the periodic table to figure out what the charge is. So here's chlorine. It has 7 valence electrons. It wants to get to the valence electron configuration of argon. It wants to have 8. So it's going to gain 1 electron. When it gains 1 electron, it'll have a -1 charge. So then to balance the charge, we're going to need 2 chlorine atoms. That's because 2 times -1 equals -2. And +2 plus -2 equals 0. Okay, and just a hint, you might want to write your charges up top because we're going to use this space for something else. So just a word of the wise. Okay, next up is hydrogen. And so we'll write an H for hydrogen. Now remember that hydrogen is one of those elements where when it's by itself, there always has to be 2 of that atom. And so other atoms like that, so we have hydrogen, other atoms like that are nitrogen, oxygen, fluorine, chlorine, bromine, and iodine. So I always remember it as the 7 + 1 rule. We have 1, 2, 3, 4, 5, 6, and those 6 make up, it looks like a 7. Right here, if you look at that, the shape that those 6 elements make out. So there's your 7, and then hydrogen is the +1. And so then for that reason, we are going to need 2 hydrogen atoms. Okay, so now let's look at the physical states of all of these. First up, it was zinc metal. Metals are usually solid with the exception of mercury. And so for that reason, it's going to be a solid. Hydrochloric acid, HCl, since this metal is dissolving in hydrochloric acid, remember anytime you're dissolved in water, it's going to be aqueous. Now, theoretically, this could be dissolved in a different substance besides water. It could be dissolved in alcohol or gasoline or a whole bunch of other substances, but for the purposes of this assignment, when I say dissolve, I mean dissolved in water, and so for that reason it's going to be aqueous. If it's something different than water, I'll probably let you know that. Okay, so to produce dissolved zinc chloride, so again, this one is dissolved, so it's going to be aqueous, and hydrogen gas. And since it's a gas, we'll write that one as a gas. So solid, aqueous, and gaseous. Okay, and then, and if you're, the only other state something would be in one of these types of equations would be liquid, and so then you'd write an L instead of a G or an S. Okay, next up, let's balance the equation. So we've got zinc, chlorine, and hydrogen on each side of the equation. I count 1 zinc, 1 hydrogen, 1 chlorine on this side. So 1, 1, 1. On this side, I count 1 zinc, 2 hydrogen, and 2 chlorine. So 1, 2, 2. We're going to fix that by adding a 2 in front of HCl here. And that's going to make it so that we have 2 hydrogen and 2 chlorine on this side. So now everything is the same. Last up, we need to classify this. You can see here we have 1 element and 1 compound, and on the other side we have 1 compound and 1 element. Whenever an element is replacing one of the elements in a compound, that's always going to be single replacement. One thing I do want to point out here is this is a little bit of a weird single replacement because the compound didn't have a metal in there. So zinc was replacing hydrogen, which is a nonmetal. In acids, hydrogen, even though it's a nonmetal, it's sort of acting like the metal. And so that's why zinc replaces hydrogen and not chlorine. It's because this is an acid, and in an acid, the hydrogen acts like a metal. Okay, so let's do one more example. In this example, chlorine gas and dissolved potassium iodide react to produce dissolved potassium chloride and sodium iodide. Okay, so first up is chlorine gas. Chlorine is Cl. Again, though, chlorine is one of those elements, right? It's in the 7. It's right here. And so when chlorine is by itself, that means that there's actually 2 chlorine atoms. They covalently bond with one another. Whoops, what am I doing? Okay, so this becomes Cl2. And chlorine gas, and then it looks like dissolved potassium iodide. So Ki. So we should check the charges on there. Potassium has 1 valence electron. It'll lose that electron to form a +1 charge. Iodine has 7 valence electrons. It'll gain 1 electron to have a -1 charge. And then +1 for potassium, -1 for iodine. And so for that reason, this one's already balanced. +1 plus -1 equals 0. Okay, and so then they react to produce. And so that's where our reaction arrow goes. Produce, they're going to produce dissolved potassium chloride. So up next is potassium chloride. Again, we'll take a look at the charges. Potassium is still +1. Chlorine, we can see that that one's just a little bit higher up than iodine in the same group. It also has 7 valence electrons, just like iodine. So that means it's going to gain 1 to form a -1 charge. We can see that +1 and -1 will cancel out to give us 0. So this one's already balanced. We don't need to add any subscripts. Okay, and then last up is solid iodine, so +I. But again, iodine, it's one of the ones that's in this 7. So be on the lookout for elements that are in the 7. It's these 6 and hydrogen. 7 plus 1. Okay, and so since iodine is in the 7, there should be 2 iodine atoms because iodine doesn't roll alone. They always come in pairs. Okay, and so then next up, let's do the states of matter. So first up is chlorine. It says here that chlorine is a gas, so it's going to be Cl2 gas. Potassium iodide is dissolved, so that means it must be aqueous. Then they react to produce dissolved potassium chloride, so that one's also aqueous. And solid iodine, so that one's a solid. Okay, and so then last up, let's balance the chemical equation. So on each side we have chlorine, iodine, and potassium. So on the reactant side, looks like we have 2 chlorines, 1 potassium, 1 iodine. On the product side, it looks like we have 1 chlorine, 1 potassium, and 2 iodine. Okay, so we'll start by trying to balance the chlorine. So we'll add a 2 in front of potassium chloride. Now that makes it so that we have 2 chlorine and 2 potassium on this side. So now to balance the potassium and the iodine, we'll put a 2 in front of potassium iodide. Now we'll have 2 of each kind of atom on each side. Okay, and so then final step is to classify this reaction. Again, we have 1 element and 1 compound on each side. 1 compound, 1 element. Whenever you have 1 compound and 1 element on each side, that should be a dead giveaway that's a single replacement. So this one's another single replacement. Okay, give the practice problems a try. And if you have any questions, feel free to contact me and I will give you some help.